So there are three sort of styles to plot direction fields of a differential equation, right? So in the first style that we introduced in this lecture, and we have used it throughout the lecture, so just according to the definition, so notice that in the first example, so all the vectors, they have this form where or maybe let me do it like this, that the x component of every vector is the same, is 1, well, proportional to 1, whatever. It means that vectors that are very steep, they seem longer, and vectors that are not so steep, they seem shorter. Right? So that's one way to visualize a differential equation, but more often than not, it's not the best way. For instance, so this is probably not a very good example, but of course you see that somewhere here vectors almost overlap, and here they are probably too short to actually form, to capture the length and the direction with the naked eye. So the good area is probably somewhere here where it is clearly seen what's going on, so you can really see the head of the arrows and the direction. So a solution to this is instead of preserving the x-coordinate of all the vectors, is to preserve the direction, right? So here in the second example, so the length of all the arrows is the same, right? So here some if I want to draw a horizontal arrow, I would do it like this. Almost vertical arrow will have a different x value, but this the same length. Well, and finally, the third sort of style is to not to plot directions at all, so to delete arrowheads, and just little lines, right? So the problem that I have tried to figure out how you can modify the MATLAB code provided to get the second and the third styles.